Hello everyone, welcome to my presentation. In the previous video, we learned how a machine learning model is trained, tested, and finally deployed so that real user can start using it. Today, we are going to continue that journey by learning what happened after the deployment. Our topic is machine learning model monitoring fundamental. Many people think that once a model is deployed, the project is completed. However, that is not how machine learning works in the real world. A deployed model continues receiving new data every day, and because the real world keeps changing, organizations must regularly check whether the model is still performing well. In this presentation, we will learn why monitoring is important, how AWS helps monitor deployed models, and how organizations keep their machine learning systems accurate and reliable over time. So let's get started. So before we understand monitoring, let's first think about what happened after a model is deployed. Imagine a company has built a machine learning model that recommends product to customers. The model is tested, approved, and finally deployed to the company's website. At first, everything works perfectly. Customers receive good recommendation and the business is happy. But after deployment, sometimes new happens. The model starts receiving real customer data every day. Every customers behave differently. Some customers buy new products, some change their interest, and market trends continue changing throughout the year. The model now has to work with information that it never saw during training. This means the job of the machine learning team is not satisfied. Instead, a new responsibility begins. They need to continuously observe how the model is performing. Is it still making good predictions? Is it responding quickly? Are customers receiving useful recommendation? This continuous checking process is called model monitoring. You can think of it like owning car. Buying the car is only the beginning. To keep it running properly, you regularly check the engine, change the oil, and perform maintenance. Machine learning models work is in exactly the same way. Deployment is only the beginning. Monitoring keeps the model healthy over time. So let's move to the next slide. Now you may ask an important question. If the model worked well during training, why would it suddenly become less accurate? The answer is very simple. Because the world keeps changing. Remember, a machine learning model learns from historical data. It only knows the patterns that exceed when it was trained. However, after deployment, new situations appear every day. Customers' interests change, business launches new products, people change their shopping habits, economic conditions change, even season can affect customer behavior. Imagine a clothes store. During winter, customers mostly buy jackets, sweater, and boots. But when summer arrives, customers begin buying t-shirts, shirts, and sunglasses. If the model was trained only using winter shopping data, its recommendation during summer may no longer to be accurate. The model itself is not broken. It is simply making prediction using old knowledge while the real world has already changed. This change usually happens slowly. Organization may not notice them immediately. That is why monitoring is so important. It helps engineers discover these changes early so they can update the model before customers begin receiving poor prediction results. Let's move to the next slides. So now let's understand what model monitoring actually means. Machine learning model monitoring in the continuous process of checking how a deployed model perform after it start working with the real user. The main goal is to make sure the model continues producing accurate, reliable, and consistent predictions. But what exactly do organizations monitor? They don't only look at prediction results, they also check many other things. For example, is the model still accurate? How quickly is it responding? Is the system using too much CPU or memory? Has the incoming data changed? Are there any unusual errors? By collecting all of this information, Engineers can understand whether the deployed model is still working properly. Monitoring also allowed organizations to solve problems before customers notice them. Instead of waiting for users to complain that recommendations are wrong or predictions are inaccurate, customers receive early warning signs from monitoring tools. This allows them to investigate the issue, retrain the model if necessary, and deploy an improved version before the problem becomes serious. A simple way to understand monitoring is to compare it with a regular health checkup. Even if you feel healthy, doctor recommended regular checkup because they can detect small problems before they become serious illness. Model monitoring works exactly the same way. It continuously checks the health of a deployed machine learning model to make sure every continues working correctly. Let's move the next slides. So now that we understand why monitoring is important, let's learn about one of the AWS service that help organization perform this task automatically. So the service is called Amazon SageMaker Model Monitor. The easiest way to understand Model Monitor is to think it's a as a quality inspectors for your machine learning model. Imagine a factory that produces thousands of products every day. Instead of checking every single product manually, the factory has an automated quality control system that consistently checks whether everything is being produced correctly. Model monitor work in a similar way. After a machine learning model is deployed, machine learning continuously check how it is performing. It doesn't only look at the prediction results, it also look at the data being sent to the model. When it compares this new production's data with the original training data, why is this comparison important? Because if the new data starts looking very different from the training data, predictions accuracy may begin to decrease. Instead of waiting until customers notice incorrect predictions, Model Monitor detects these changes early and alert engineers that something may need attention. This saves time and help organizations maintain reliable machine learning systems without manually checking thousands or even millions of predictions requests every day. Let's move to the next slides. So the next AWS service is Amazon CloudWatch. So while model monitor mainly focus on the machine learning model and its data, CloudWatch focus on the overall health of the system. Think about the dashboard in your car. When you drive, the dashboard shows information like speed, fuel level, engine temperature, and warning lights. CloudWatch works in a similar way for AWS services. It continuously collects important systems information, also called metrics. For example, it monitors CPU usage, memory usage, response time, request count, and whether the SageMaker endpoint is available. By looking at these metrics, engineers can quickly understand if the deployed model is working normally. CloudWatch can also create automatic alarms. Imagine that suddenly thousands of users start using the applications at the same time. If response times become slow or too many errors begin occurring, CloudWatch immediately sends a notification to the engineering team. This allows them to investigate and solve the problem before it affects many users. So while model monitor checks the quality of the model, CloudWatch checks the health and performance of the entire machine learning system. Together, these two AWS service help organizations maintain reliable predictions environments. Let's move to the next slides. So now let's learn one of the most important monitoring concept called data drift. The name might sound complicated, but the idea is actually very simple. Data drift means that the information being sent to the deployed models has gradually become different from the information that was used during training. Notice something important. The machine learning model itself has not changed. The world around the model has changed. Let's use a simple example. Imagine an online shopping company trained its recommendation model using customer shopping data from last year. Last Last year, many customers were buying laptops and office equipments because more people were working from the home. This year, customer interest may not change. Now people may be buying travel bags, sports equipments, or vacation items instead. The deployed model is still using patterns learned from last year's data. Because customers' behavior has changed, its recommendation may slowly become less accurate. This situation is called data drift. Data drift does not mean that the model has failed. It simply means that engineers should review the model and decide whether it should be updated using newer data. Detecting data drift early help organization improve the model before customers begin noticing incorrect recommendation or a poor prediction quality. Let's move to the next slides. Now that we know data can change, the next question is how do organizations know whether the model is still making good predictions? The answer is model quality monitoring. Model quality monitoring focus on checking whether the prediction accuracy remain high after deployment. Here how it works. The deploy model makes a predictions. Later, when the actual results become available, engineer compare the prediction with what really happened. For example, imagine a bank uses machine learning model to approve loan applications. The model predicts that the customer is likely to repay the loan. After several months, the bank know whether that prediction was correct. By comparing the predictions with the real outcome, engineers can measure how accurate the model still is. If prediction accuracy begins decreasing, it doesn't always mean something is broken. Sometimes it simply means that customer behavior has changed and the model needs to learn from newer data. This is why organizations continuously monitor prediction quality. Accurate predictions help business make better decisions, improve customer satisfaction, and maintain trust in machine learning systems. Without quality monitoring, organization might continue using a model that slowly become less reliable without realizing it. Let's move to the next slide. So now let's move on to another important AWS features called auto scaling. Imagine your own online shopping website. On a normal day, maybe only a few hundred people visit your website every hour. But during special events like Black Friday, Cyber Monday, or holiday sales, thousands or even millions of people may visit your website at the same time. Now think about what would happen if your machine learning recommendation system was designed to handle only a few hundred users. When thousands of customers arrive, the systems may become slow or even stop responding. This creates a poor experience for customers. To solve this problem, AWS provides auto-scaling. Auto-scaling automatically adjusts computing resources based on the number of requests being received. When traffic increases, AWS automatically adds more computing resources so the deployed model can continue making prediction quickly. When traffic decreases, AWS automatically remove the extra resources that are no longer needed. This is very helpful because organizations do not have a manual increase or decrease their server every day. They also avoid paying for resources that are sitting unused. So auto-scaling or not only improve applications performance but also help organization reduce cloud cost. Let's move to the next slides. So now that we understand that different monitor service, let's put everything together and let's see how the complete monitoring process works. The process begins when a customer or an application send new information to the deployed machine learning model. For example, a customer may make an online payment or search for a product on a shopping website. The deployed model receives this information immediately, generate a predictions. At the same time, AWS monitors serving being collecting information. AWS CloudWatch monitor the health of the system by checking response time, resource usage, request count, and other performance metrics. Amazon SageMaker model monitor focus on the machine learning model itself. It checks the incomplete data, compare it with the original training data, look for change that cloud affect predictions quality. If either service detects a problem such as slow response time, changing data, or decline predictions quality, it automatically sends an alert. The engineer teams that investigate the issue, if they discover that the model need improvement, they retain it using newer data, test it again, and deploy the updated version. Then the entire monitoring cycle continues. This process keeps the machine learning system accurate, reliable, and ready for real-world use. Let's move to the next slides. So now we'll understand everything using a real business example. Imagine a bank uses a machine learning model to detect fraudulent credit card transactions. Every time a customers make a payment, the deployed model immediately analyzes the transactions. It look at information such as the purchase amount, location, spending history, and other patterns it learned during training. If the transactions appear suspicious, the bank can quickly investigate or temporarily block the payment. During the first few months, the model performs very well because customer behavior is similar to the data used during training. However, over time, criminals begin using new fraud techniques. These new patterns were not included in the original training data. Because of this, the model may slowly become less accurate. This is where monitoring becomes extremely important. Amazon SageMaker model monitor detects change in the incoming transactions data. CloudWatch checks whether the system is still performing efficiently. If monitor tools detect uh, declining performance, engineers investigate the issue. They collect newer transaction data, retrain the machine learning model, test it carefully, and deploy the improved version. This is continuous cycle help the bank detect fraud more accurately while protecting customer accounts and maintaining trust in its services. Let's move to the next slide. So before we finish, let's discuss some of the best practice that organizations follow when monitoring uh, mo- machine learning models. The first best practice is to monitor models continuously instead of waiting for users to report problems. Finding issue early help prevent bigger problem later. The second best practice is to regularly review predictions accuracy. Organization compare predictions with real business outcome to make sure the model is still making good decisions. Another important practice is monitoring both the machine learning model and the systems that support it. Model may still be accurate, but if the machine learning becomes slow or unavailable, customers will still have a poor experience. Organizations should also use automated AWS service such as CloudWatch, Amazon SageMaker model monitor whenever possible. Automation save times and allow engineer to monitor large productions systems much more efficiently. Finally, organizations should retrain machine learning model whenever monitoring shows that predictions quality has declined. Machine learning is not a one-time activity; it's continuous process of learning, improving, and adapting to new business conditions. Let's move to the next slides. So this brings us to the end of today's presentation on machine learning model monitoring fundamentals. In this presentation, we learned that deploying a machine learning model is only the beginning of its journey. We explored why machine learning models change over time, why monitoring is necessary, and how AWS services such as Amazon SageMaker model monitoring and Amazon CloudWatch help organizations maintain reliable machine learning systems. I hope this presentation has helped you understand how monitoring keep machine learning systems accurate, reliable, and ready for real-world applications. Thank you so much for taking the time to watch my presentation. I would like to sincerely thanks to my professor Dr. Vikram Govindaswamy for his guidance, encouragement, and support throughout my learning journey. Thank you once again, and I hope you enjoyed my presentation. Have a wonderful day.